Good afternoon, guys. I'm just back from my hike and I'm going to go over some ROP uh, gadget use in a very vanilla ASLR DEP turned off vanilla buffer overflow. So let me get to my working files here. Okay, so let's jump right into GDB and we will haul apart the vulnerable binary. Disassemble the main function here. Let me open my window right up. And as we come down through, we can see a function here, which is very aptly named vuln function. So let's disassemble the vuln function. I wish they were all called vuln function. That makes stuff a lot easier. And once we get into the vulnerable function, we can see the str copy, which doesn't do bounds checking. So that's a place for us to exploit. So we'll copy this. Let's put a breakpoint just before it copies our input into the file. And as you can see, our breakpoint's set. Now I need to find the size of this buffer. So what I'll do is I will open a new terminal here. And Python. This is my program Freya, which I use. Sorry, spelled it wrong. Freya. Program I made just to put all my exploitation files I've written together, and it works pretty good. So first thing I'm going to do is run my fuzzer and make a length of block of just ASCII code. So it's just random code. So I'm going to say I want 2,000 characters in the block of code, and it is written to the output.txt. So next I'm just going to open up the output.txt here. I'm going to copy this and we can get out of here. Next I'm going to exploit this is where I actually write the exploit. So what we will do is put the output of the fuzzer there. And let's get back down here and we'll just do a print statement of fuzz. And let's file, save that, and we're done there. And this is my own fuzzer I made up. So now I'm going to turn it into a binary. So turn exploit into payload, and that should be done. So now what I can do, I come down here and I do run and cat my payload, which is just my fuzzer. And as you can see, all this right here is the random characters. Now, what I need to do, I need to get the return address overwritten and find out the size of the buffer. So that's the only reason I have GDB open at the moment. So I'll just hit continue. And as you can see, we have a SIG-SEV segmentation fault. And if you come over here to EIP is overwritten with SVTH. Okay, so that's cool. So if I just hit my run offset.py, it says here enter, whoops, wrong window. Enter the string to look for. So we just take what was overwritten EIP. And as you can see, the string was found at offset 268. So now I know my buffer size is 268 bytes. So I'll just continue on here and exit the program. So now let's go back to our exploit. So now I can take this fuzz stuff out. And what I'll do, I'll just rename this buffer. And inside this buffer, I'm going to have A times 268. I think that's what the offset was. Let me just double check that. Whoops. And yes, it's 268 bytes. So that gives us the size of our buffer. So now we can start doing our exploit. So we can save this file, save, and actually what I'll do, I'll put the return address that we're going to overwrite, and I'm going to put in, this is equal to 4Cs. And we'll file and save this. Now I'll turn this into a binary just with my Freya program here. I like having, we can close this window down right now. It's not doing anything for us. And we turn in exploit fuzz is not defined. Whoops. Okay. So let's go back to our exploit. Just a little mess up here on my part. And print, we're going to print buffer plus ret. So that was my fuck up there. So let's do that. Let's turn it into payload. Looks like it ran good. So now we'll open up a new terminal. And cd to my tooling and gdb/q vuln2, the name of our program. And I'm just going to go right to the vulnerable function, and I'll set my breakpoint here, right here at the stir copy, which doesn't do bounds checking, so we can make it our bitch. And that's set. So now I can run the program with my new binary payload that's going to fill up the buffer and the return address. So here we go. So we can see that the A's are loaded up. I can display 132 words of hex from the stack pointer and hit next instruction. This will load up everything onto the stack. So let's have a good look now at the stack. And as you can see, here's all our A's here. And here's our C's that's overwriting the return address. So now to control the execution of flow, and what I'm going to do with this jump ESP is I'm going to put a gadget right here at this return address that says jump to ESP. Now ESP is going to be pointing to this part of the stack right below the return address. So what I'll do, we'll keep this buffer the same. We can put anything in for this buffer that we want. We'll put our return address here. That is our jump ESP gadget. This is where we'll put our gadget. And then our shell code, which is 24 bytes, will sit here. This gadget will jump it to here, and we should get shell. Clear as mud. Okay, so let's go back to our exploit. Open exploit in. So now this C here, we need to find out, we need to get the gadget. So what I use for gadgets, actually here we have, I use Roper for gadgets, but the Roper only gives the offset. So you need the base address of the libc library to add on to this offset to get the actual calling address. So I'll show it instead of explaining it. So let's do VM map first. And as you can see, the libc library starts at this address right here. So this is not an offset, this is the actual address. So let me just put a comment in here to keep control of this. Perfect. Now let's go to Roper. Let me exit out of here and locate libc.so. Oh, let me just quit out of Jeff here. So first I got to find the libc, full libc library. Whoops, I made a little error there. Let's go back and try that again. Okay, perfect. We need this address to put into the beginning of our file here. So let's select this And now all this program is doing is looking for all the different return-oriented programming gadgets that we can use. So this takes a second to load up. So um, we'll just give it a minute here. So we already have our base address. So now once we get this offset, we will add it with our trusty calculator and our programmer calculator, of course. And we're just loading up. I had a really great hike out seeing some eagles fighting. That was kind of cool. And we're at 90%. Okay, so now I'm going to search with a depth of 1, jump ESP gadgets. And here's our jump ESP gadgets, but as you can see, this isn't an address, it's an offset from the base address of the libc library. So let me just come over here and we'll put this in here so I don't mess up. Now let's haul up our calculator. So we have whoops. Let's do hex. And I have 2AA9 plus B7E0 7000. So B7E0, B7E0, 7000. So this is how you calculate the address for the actual jump ESP gadget. So this is in libc library, so use it against itself, right? Use the program against itself, which is amazing. So now what I'm going to do, I'm going to put this into our placeholder here we had for 4Cs. So we'll put this in backwards. So it would be, that did not come across. That is not right. Yeah, I knew that wasn't right. So here we have B7E0. Here we go. I knew that wasn't right. Just didn't make sense in hex. 9AA9. So let's put in 9AA9. Okay, so first off, we have A9. And then we have 9A. Then we have B0. And then finally, we have B7. Okay, so all we need next is our shell code. Let me just grab it from in here. And this shell code, I showed everyone how to make binsh shell code the other day. So I won't get too into it here today. If you want to find out, just go back and have a look at my videos. So let's put, now the shell code's going to go below our ret. So we'll just put a shell here equals, and there's our shell. Let's put some quotes around it to make everything copacetic here. Okay, and then we need the place shell. So now I need to save this and open up Freya and turn exploit into payload. Oops, hold on, I gotta close this exploit down first. So let's turn exploit into payload. And I think we're copacetic there. Let me just close down this terminal. Yep, everything's good there. Okay, so now we should be done with Freya for now until we do our finalized payload. So let's have a look at GDB, and we'll see if we can exploit this. Tooling GDB/Q phone 2, and disassemble the vulnerable function. We come down to the stir copy, which is going to be vulnerable for us. And let's put a breakpoint in there. There's the breakpoint. Now we can run with our payload. Spell it right. Our payload. And let's see what happens here. Okay, so I'm just going to hit next instruction, which will load our input into the stack and turn words of hex from the ESP. So as you can see, our A's, what I'll do as well here is open up our exploit. And I'll just shut this down over here somewhere. And let me look at your tooling here. Let's get rid of this. Okay, so as you can see, we had a buffer of 268 A's. So that is all these right here. The next is going to be our jump ESP, and that does not look right. So I've done something wrong here. Oh, I see exactly what I did wrong. See this? So this is how you fuck it up. And this is why we run it through a couple times and we go back because we all can make simple little mistakes like this. So that looks good now. Let me put this in again. A9, 9, A, E0, B7. So let me save this. Save. And now let's open up my Freya again. And let's do Python Freya.py. Whoops. Freya.py. Here we go. So let's open our exploit. Everything looks good in our exploit this time. Let's turn it into payload. The payload worked. So now what I'll do, as you can see, as soon as I debugged it, I seen that this was not the address I wanted on a return address because I had the slash backwards. So let's continue. And as you can see, we had a sig fault and program is no longer running. Let's run that program again with our updated payload. Okay, so let's display 132 words of hex from the ESP. And as you can see, nothing is loaded up because we're right before our stir copy right here at the vulnerable function. So let's hit NI for next instruction. And let's bring back our display. And as you can see, let's bring up our exploit again. So let's have a look at this exploit along with our program here. And as you can see, the A's have all filled up to here. Once we get down to the return address, you can see that B7, E0, 9A, A9. So this is our ROP gadget that will jump to where the ESP sits. Now the ESP is sitting right here. It will come down here and it'll grab this 31C0, 89C1. This is our payload, our shell code right here. So if everything works, this should jump right into our shell code and we should get a shell. And as you can see, ta-da! Is executing new program bin dash. Dash is a smaller, lighter weight bash, but we have got system shell. So I hope that was simple and fun for you guys. It's just a basic introduction in ROP gadgets, which I really, really, really love. So I found this a better way than doing the pop ret stuff I showed you guys before. So in the next couple days, I'm going to put out another one about jumping to registers. So like jump EAX, stuff like that. And we can play around a lot with the execution flow and take over some systems. I hope you guys enjoyed, and I will chat to you guys really soon. Please share if you enjoyed. Thank you. Bye.